Greetings, detectives. Mrs. McKay here, and we are moving on to features of exponential functions, which is our learning target clue 5-2 from case 5. Let's go ahead and fill in our learning target. I can identify the key features of an exponential function including domain and range, intercepts, and horizontal asymptote. That's a brand new word. Asymptote. I can identify the key features of an exponential function including domain and range, intercepts, and horizontal asymptote. So before we do anything more, let's go ahead and do a quick review. We know what an exponential function looks like. It's usually got a graph that looks like this or a graph that looks like this, right? Not bending back like that though. But let's remember what the equation of an exponential function is. Remember that it's f of x or y equals a times b to the x power. Okay, a times b to the x power. The a is often where we start, where x is 0, and the b is our constant ratio or the change factor, the thing that we are multiplying over and over and over again. And the x is the number of times we're going to multiply it over and over again. And the thing that makes an exponential function so different and interesting is that the x is the exponent. All right? Now, before we do anything more, though, I want to make sure that you understand negative exponents. And I don't know if you've ever been introduced to them. So we have a number like 2 to the second power. And that just means 2 times 2. Yes? Yes. And we also have 2 to the first power. And that's just 2. And I think I've mentioned to you 2 to the 0 power is always 1. And now I want to talk to you about 2 to the negative 1 power. 2 to the negative 1 power. So let me do this over here. Let's start with 2 to the third, 2 to the second, 2 to the first, 2 to the 0, 2 to the negative 1, 2 to the negative 2 to the negative 2. All right? 2 to the third is 2 times 2 times 2, which is 8. 2 to the second is 2 times 2, which is 4. 2 to the first is 2, which is 2. And now what I want us to think about is what did we do? What did we do to 2 to the first to get 2 to the second? Well, we multiplied by 2, didn't we? Each time we multiplied by an additional 2. So we took 2 to the second, or 2 to the first, which is 2. We multiplied it by 2 to get 4. We multiplied 4 by 2 to get 8. We kept multiplying by 2. So the question is, if we have 2 to the 0, what number do we have to multiply by 2 to get 2? What number goes here that when we multiply by 2, we get 2? Well, this number has to be 1. 1 times 2 gives me 2. So that's how we get 2 to the 0 equals 1. All right? 2 to the 0 equals 1 because it's almost like where you start. All right? Then the next thing is, what do we have to multiply by 2 to get 1? So now we're going to start going to the negative exponents. What number, when we multiply it by 2, do we get 1? Well, it's really 1/2. So 2 to the negative 1 is really 1/2. And what number do we multiply by the 2? What number do we multiply 2 by to get 1/2? Well, it's really 1/4. 1/4. 1/4 times 2 is 2/4, which becomes 1/2. So let me show you what we have here. X squared is equal to x times x. X cubed is equal to x times x times x, yes? And x to the 4th is equal to x times x times x times x. X to the 1 is equal to x. And what do you think x to the 0 is equal to? X to the 0 is equal to 1. And what do you think x to the negative 1 is equal to? Well, it's equal to 1 over x to the 1 power. And x to the negative 2nd is equal to 1 over x to the 2nd. And I have a little phrase that I use that is cross the line, change the sign. So that means if I have x to the negative 3rd, and I think of this as a decimal, or not as a decimal, as a fraction, x over 1. If I take my base and I cross the line, okay, then I end up with x down here, and I change the sign of my exponent to the 3rd, and I put my 1 up there. All right? Cross the line, change the sign. So if I have a negative exponent, I can move it across this division line, and it now becomes a fraction. You may or may not have known that, and if you didn't, and this is brand new, just always remember that, let's go back over here. This is going to be 1 over 2 to the 1 power. There's going to be 1 over 2 to the 2nd power, or 1/4. All right? So that's just going to help us to be able to solve some problems. All right. Now let's go ahead and look at some key things. Let's start by completing this table and sketching a graph and determining the features of this function f of x equals 3 times 2 to the x power. So 3 becomes our a, 2 is our b, and x is our exponent. All right, so if x is negative 2, then I have to think, let's see, I'm running out of space here, but I'm going to use red. I have to think 3 times 2 to the negative 2nd power. Now I just got done saying that if I have a negative exponent, I cross the line, change the sign. So I keep my 3 up here. But now I'm going to move my 2 to the negative 2nd power down here, and I'm going to change the sign. So it becomes 3 over 2 squared, which is equal to 3/4. All right? 3/4. And now I have 3 negative 1. So if I have 3 times 2 to the negative 1, well, 2 to the negative 1 is just really 1 over 2 to the 1st. So that becomes 3 over 2 to the 1st power, which becomes 3/2. All right? 3 to the 0, 3 times 2 to the 0 power is 2 to the 0 becomes 1, because any number to the 0 power is 1. 1 times 3 is 3. And then we have 3 times 2 to the 2nd power. And I get 3 times 2 to the 2nd. 2 to the 2nd is 4. 3 times 4 is 12. And 3 times 2 to the 3rd power, well, 2 to the 3rd power is 2 times 2 times 2, which is 8. So 3 times 8 is 24. Now what I'd like us to do is I'd like us to go ahead and graph this. Let's go ahead and start by graphing negative 2 3/4. So I have to go negative 2, and 3/4 is going to be right about, it's a little bit closer to 1/2, but you get the idea. There's 3/4, all right? And negative 1 is 3/2, which is just 1 1/2. So I'm going to go 1 1/2 right here. And then 0 is 3, so that's 1, 2, 3. And 2 is, well, I don't have 1 up there, do I? Let's go ahead and put a 1 in there. I'll do the 2, and then 2 is 12, so 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 goes there. And I'm going to go ahead and fit my other one in there too. So if I have x to the 1, that would be 3 times 2 to the 1, which is 3 times 2 is 6. So 1, 2, 3, 4, 5, 6. There we go. And then 3 is 24. So if this was 12, we've got 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, right there. All right, so there's my exponential function, and you can see it. Kind of looks like that. It's terrible, but you get the idea. Now, we're going to answer a couple questions. First of all, what is the x-intercept? Meaning, when does this graph reach 0? Well, it really never does. Because let's think about this. If we kept going in the negative version, if we did x was negative 4 or negative 24 or negative 15, it would always be 2 to the negative whatever we put there. We'll just say negative x, which means it's 1 over 2 to the x. So it's just going to get smaller and smaller and smaller and smaller, closer and closer and closer and closer to the x-axis, but we're never going to touch it. We're never going to touch it. It's going to get very close. It's going to get so close that we can't see it unless we had a microscope, but it's never going to reach it. So there is no x-intercept. But what is the y-intercept? Well, the y-intercept is 1, 2, 3. So we'll write it as a 0.03. And that happens to be when x is 0, right? Now the next one is the asymptote. And the asymptote is this new term. And the asymptote is the horizontal line that our function approaches but never gets to. And what is that line? Well, that line is our x-axis, which is x equals 0. Sorry, y equals 0, not x equals 0. Y equals 0. When y equals 0, that's our x-axis. And then what is the domain? Well, the domain is all of the x values, all of the possible x values, and we can have just about any x value. We can go all the way out here. We can go all the way over in the positive direction or the negative direction. We can put any number in for x. So the domain is the real numbers. Our range, however, is our y values. And do you notice that there is a very particular part of our coordinate plane that is not having any graphing in it? It's everything below y equals 0. So our range is y is greater than 0. That means anything that's greater than 0. Y will never be 0 because our asymptote is y equals 0. And the last thing is this an increasing or a decreasing? Is it increasing or decreasing? Well, you can see that it's increasing. Come back for part 2, and we'll do the last one.